Welcome back everyone. In last chapter we discussed what were the different type of conveyors, what are the different type of accumulation conveyors, where they are deployed, what are their typical application areas. So all these things we discussed in part 1. In part 2 we'll be discussing about how to design or to calculate these conveyors, and in part 3 we'll be talking about the 3D designing of the accumulation conveyor. So let's start. So in this part we'll be discussing how to design and what is the design process. So let's start with some basic things. What we'll be calculating? We'll be calculating chain selection, motor selection, section design and selection. And in next chapter we'll be discussing about the 3D designing part. So let's start with the chain selection. For chain selection we'll be needing following things. What is the weight of pallet? What is the weight of workpiece? What are the pallet dimensions like length, width and height? Another thing we'll be needing is that how much is the length of conveying portion and what is the weight on conveying portion, what is the length of accumulation portion and how much weight is on the accumulation portion. Little bit about our company. This is Ideas Made Reality and a chief mechanical designer. I'll be explaining you all about the calculation part as well. Ideas Made Reality caters to all the design and development of special purpose machines, automation requirement, prototype building, and 3D or 2D outsourcing of various organizations. So if you have any work related to this, feel free to contact us. So if we have excessive weight, then our section will sag, resulting in deflection more than required or even failure of the section of accumulation conveyor. Second thing is, which very few people think about, is when the load on the roller is more than desired, then the entire internal section buckles and the top of the roller moves below the top surface of the section. This results in pallet actually resting on the surface of section rather than resting on the roller. In industry, I have seen this problem many times when the selection is borderline or selection is not done appropriately. Everything runs fine, but after a period of time, this section sags, resulting in pellet getting stuck on the accumulation conveyor because it is not in contact with the roller, or sufficient drag cannot be transferred to the pallet, and pallet rested on the conveyor section leads to halt of the entire accumulation section or the station. Another thing which is important, when there is a plastic roller instead of steel roller, then excessive weight can result in the flattening of the plastic roller as well. So that is why the pallet weight, the workpiece weight and the forces which will be exerted onto the pallet are really important, because those will be directly getting transferred to the accumulation conveyor or the section beneath it. What are the prerequisites which will be required in order to calculate? Pallet width, pallet length, pallet height. What is the payload we are expecting on pallet? Yes, it is an accumulation conveyor. 20 meter per minute is the required transfer speed. In industry, especially in automotive industry, the most common speeds used are between 15 meter per minute to 20 meter per minute. Now conveyor length will be 10 meter and there will be total 6 stations on this conveyor. Pitch of station will be 1 meter, as these are totally correlating. This is the width and length of the pallet, and the station pitch is 1 meter. And total number of pallets are 8. That means at a time 6 pallets will be working on a station, 1, 2, 3, 4, 5, 6, and there will be 2 pallets which will be waiting for their turn. So there will be total 8 number of pallets at a given time on the conveyor. Maximum load per meter on the conveyor. Why this will be required? This will define the weight on the individual roller and on the section. Both should be below the allowable weight limit. Weight of pallet and workpiece. This will be required additionally to calculate motor power, tension of steel. Then the environmental condition. This is really important. If you are in a pharmaceutical industry, let's say if you are in food industry or you are in different industry where you need a clean room environment and special lubrications are to be used, you need to be very careful about the rollers and link material which you're using. You might have to go for polyurethane roller or nylon roller, or maybe chain can be of stainless steel. So all these things needs to be considered before we can jump into selection of material. Then material of pallet. This is why this is important, because it will directly impact the roller life. If pallet is of stainless steel, let's say hardened stainless steel, and underneath you have a plastic roller, then life can be seriously compromised. In such cases, it is recommended to have plastic roller under the steel roller under the steel pallet. Talking about the conveyor speed, this has the direct relation with the motor power selection. And then conveyor length again, it is required for tension, chain tension, and hence the motor power calculation. Then accumulation stations, again same thing. Checking the allowable roller load. So how much load on a particular roller will be exerted when there is a total weight or the maximum weight on the conveyor. So in this case, roller load per meter can be calculated by total pallets and workpiece weight in kilonewton. This is total pallet weight, not the number of pallets. When workpiece weight in kilonewton into 1000 divided by pallet length. Now why I have multiplied with by 1000? Because pallet weight is in mm and the desired result is in kilonewton per meter. And then there is very peculiar thing I multiplied by is 0.6. Why 0.6? Because it is very difficult to have 50-50 weight distribution on the both strands of chain. This is the pallet, this is one roller, this is another roller. So it is almost impossible to have 50-50% distribution. So a good guess is to take 60% on each roller, so that we have a conservative approach and more realistic approach. So from here we calculated, based on our previous assumptions, 1.6 kilonewton meter is the exerted weight on the rollers. So based on this, we have done a chain selection, which is roller dia is 36.6 millimeter and the pitch of chain is 38.1 millimeter. And the mass of chain, this is required for further calculation, is 5.6 kg per meter. Roller material we have selected is steel, and the allowable load for this particular chain is 2.35 kilonewton per meter. There are different suppliers who provide accumulation chain. You can get all this information from their catalog. Next, we'll be calculating the chain tension, which is really important for calculating the motor load. So let's start with what we'll be needing. We'll be calculating the maximum load applied on the chain, which will be calculated by length of the conveying section, weight on the conveying section, length of the accumulation section, and weight of the accumulation section. Then we have three coefficients of friction factors. Then mass of the chain, which I mentioned in the earlier slide. So from this we'll be able to calculate the motor power. For that we'll be needing the speed of the transfer, efficiency of the transfer, and the gravitational factor. So with this form, we have put our values in this formula, and these are the values which we initially assumed and got this result: 200.48 kg or 1.96 kilonewton. Now load on each chain, because this is the total load, again applying that 60% formula, for one strand of chain we have 1.18 kilonewton of force, and allowable safe load limit for this particular chain is 3.3 kilonewton. Selection of chain where allowable load is 3.75 and our load is 3.3 kilonewton. So it's a good selection. Now coming next to the motor power. Motor power in this particular case comes out to be 0.8 kilowatt. From the previous slide, we'll see the kilowatt can also be calculated by this formula. So we have just put our values in this and we got this motor power. What should be the pitch of legs? Let's say you have a 10 meter long conveyor. So what should be the pitch of legs? A very good approach is to know the moment of inertia of the section and just apply the beam formula. I just consolidated that here, assuming that there is 2 mm slack in the section. So motor can easily be calculated by, this is our angular velocity, which will be calculated by dividing the linear velocity by the radius of the sprocket. So we get the 5.4 radian per second value of the angular velocity. Now from here we'll calculate how much RPM we'll be needing. Just to simply put, n is the number revolutions per minute, omega angular velocity multiplied by 60 because we want in meter per minute, not in meter per second, divided by 2 pi, which is the standard formula for converting. Now for torque required, it is simply the tension pull on the chain divided by multiplied by the PCD, because it is a diameter, we'll be dividing it by 2 and we get the resulting 121 Newton meter torque. Next is the friction factor. So obviously there will be some losses. As a rule of thumb, I take it 0.1 because there are alignment issues, there are friction issues. If you dig deeper into the friction factor, it might come out to be 0.08 or 0.05, but there are some misalignments as well in conveyor or installation inefficiency, so it is better to keep it 0.1. This is just based on the experience. Then force required becomes is 133 Newton meter. Now calculating the motor power is simply torque multiply the angular velocity, that is T 2 pi n by 60, or you can multiply directly by omega. We get 0.65. There is a motor efficiency factor because it will be a helical gear drive and there will be some motor efficiency. The total efficiency of the entire package is 85%. This 85% I have got from the manufacturer's catalog, and the motor power is coming out to be 0.77 kilowatt. Now we'll be adding the load factor to this particular case, which is 1.35 moderate shocks, 24 hour of operation. We are assuming that in an assembly line there is a 3-shift operation and 24 hour the conveyor will be running. Selecting a gearbox with a greater than 1.35 service factor. Motor specification for this particular cases are 51.6 is the RPM, 133 Newton meter torque is required, power is 800 watt and service factor is 1.35. We have step of motors, like first we have 100 watt, let's say, then we have 200 watt and 400 watt motor. Likewise we have 750 watt motor. After that we directly have 1.1 kilowatt motor. Because our motor power is 800, we cannot deploy 750 watt motor. So we'll have to jump up to 1.1 kilowatt motor. The motor which we selected is motor RPM of 1762. After reduction, the output RPM on the motor shaft is 57 RPM. Overall gear ratio. Then this motor can provide up to 183 Newton meter torque. And the service factor is 1.65. The permissible output overhang load is 5020 Newton, 5020 Newton, and the motor power is 1.1 kilowatt. So progress which we have made so far is we have selected the chain, we have selected the conjugate sprocket, that was done with the chain selection, and the length of pitch of legs, and we have selected the motor. In the next chapter, we'll be discussing about the 3D modeling and construction of accumulation conveyor. Thank you.